So today we're talking all about breadboards, what a breadboard is, where it got its name, and how you can wire up your very first circuit using a breadboard. I've got a couple different breadboard sizes here. I've got a full breadboard, I've got a half breadboard. These are technically called solderless breadboards. But how did they get the name breadboard in the first place? Well, because this is what a breadboard used to look like. This is the OG breadboard, where it was literally a piece of wood that you would cut your bread on. And you would take screws in and you would run copper wires and wrap them around to be able to actually make a circuit. So I've got a battery pack here that's running out into this copper wire, into this lead, back here into resistor, back here into the switch, back into this wire, and then back in here. So if I flick this on, or my switch on, I should have a fully combined circuit. But you can tell that just because of where my lines are, that you don't have a great connection all the time in these. So these could be a little bit jank, which is where the benefit of a solderless breadboard came in. The great thing about these is they've got little clips inside of them that allows you to connect different devices. So if you look here, you can see these are little teeth, and we can actually see the teeth that come up. So there's actually one prong on this side, one prong on this side, and when I push a component in, like so, we can actually see that we can actually push that prong open, and that little prong holds the teeth here. Now on a breadboard, you have two power rails up at the top. Let me put this down on the bottom, zoom in. You got two power rails at the top, two power rails at the bottom. The important thing to know about these rails is that they are connected horizontally to each other. So if I were to connect a component on the red line over here, this is pretty dumb to do, but if I were to connect a component on the red line, it's the exact same thing as connecting another component on the red line over here. So anywhere that is horizontal along this red line and this blue line are connected. They are not, however, connected to each other. Same thing goes for up here. Horizontal line and vertical line. Now over here, these ones are lined up vertically. And all it is, and we can actually see down here, these ones are lined up across, these ones are lined up all the way down, and we can actually see that they're sharing the exact same rail all the way down. But these ones only share a horizontal rail. There's no connection between these two lines. So if I were to connect one unit here on line, what is that? That's line 30 to line 29, there'd be no connection between those two. I'd have to add some sort of jumper wire. So that's a base intro about how these things actually work. So let's actually talk about how would you connect devices here. Typically you'd have to provide power to this breadboard because there's no way to actually power that. You can use battery packs. I'm going to use a microcontroller here. And for the rest of this, I've got this handy dandy little 3D print here that I've set up that allows me to just connect my breadboards a little bit easier. So I'm actually going to go with 3.3 volts today. So I'm going to grab from 3.3 volts, but I need to get it from this pin over to my power rails somehow. And with that, you can use something called jumper wires. And jumper cables come in three different flavors. They come in a male-to-male end. They come in a male-to-female end, so the male end sockets into the female end, like so. And they come in a female-to-female end. For the rest of this tutorial, I'm going to be using male-to-male jumper wires to wire up our first LED. Now, it does not actually matter what color the jumper wire is. The only reason that we use these colors here is that it makes it a little bit easier for us to know what lines are going where. So let's go ahead and wire up our first circuit here. First thing I'm going to do is I'm going to go off my 3.3 volts over to my power rail. Sometimes you need to twist these things to get them in. Then I'm going to go over from ground over to my ground rail. Again, the power and ground rail are completely irrelevant here. Whichever one you choose is fine. But because my breadboard has a red and a blue strip to denote power and ground, I like to keep that just for my own sanity. Now I'm going to come off my power, and I can choose anywhere along this power rail. And just to show you that, I'm going to choose the far side. I'm going to connect to any horizontal rail I want. I'm going to connect to number 5, just for fun. Then I'm going to grab my LED. Now my LED has two ways of knowing which, or three ways of knowing technically, which side is positive, which side is negative. The long lead here is positive, the short lead is negative. I also have one side is flat and one side is round on the bottom of the LED head. The flat side is your negative side. And then inside here, you can also tell that there's two little silver toggles. This large triangle side is the negative, whereas the short side is the positive. So I'm going to take the positive to my positive ground rail here, or sorry, to my positive jumper wire. My jumper wire is on horizontal 5, so the positive side is on 5. My negative is on 6. I'm now going to grab a resistor. 330 ohm works well for this, but anything from 50 up to about 3000 will still let you see a little bit of light through. I like to fold my resistors down like so. It makes it a little bit easier to be able to plug it in. I'm going to connect this to the negative side of my LED, and then again I can choose whatever rail I want. Need to make sure that I connect it to the same rail with my next jumper wire before I get it back to my ground. So let's connect this one to my ground. Again, you can choose anywhere you want on this ground rail, so I'm just going to choose over here just to show you that it doesn't matter where I put it. And if I provide some power to this device, I should get a nice bright white LED. Two last things about breadboards today. The first one is oftentimes you're going to have to connect buttons. And on a button, you'll notice that on the bottom there's these two little nubs. This is pretty common on buttons. On the inside of breadboards, you have a little channel here. You can only connect this button in the middle of that channel. So if I were to push down all the way, you'll notice that button seats and that little nub goes inside that little split point. If I were to try to take this button and push it in over here, there's just no way for it to sit in because that little plastic nub gets in the way. Last thing you're going to want to do for your projects, I like to grab a little 0.1 ceramic capacitor and a 10 microfarad capacitor, and I add these right beside the ground rail and the power rail, like so. And what these do is this just helps you get a little more stable voltage going through, compensating for voltage sags, voltage spikes. It also helps a little bit of filtering. It's a nice little low-pass filter to get rid of some high-frequency noise from whatever power supply might be coming over here. So it'll just make your circuits a little bit more reliable. These aren't required, but it will make your life that much nicer. So I hope that helped with figuring out breadboards, and best of luck on your next project.